All right. Does that, and I'll just put that to presentation, and is that showing up well?
Looks good.
All right, perfect. So I'm James Barton. I'm the CEO of Ada Energy Solutions. And Ada is not ETA, it's the efficiency symbol for engineering design. This is a picture of our project actually probably a month and a half ago, so it's getting very close to completion. It's been a 5-year journey to design this prototypical eco-positive home. The concept was to use this residential scale as a laboratory bench scale to scale all the way up to multi-unit apartment complexes and district scale heating and cooling. But we're using this as our test subject and trialing many different improvements in residential design and building construction. So it's a factory built home. It's built in 3 different modules and then shipped to site. And here's the different design elements we'll go over in the presentation. Everything from construction, water conservation, the energy sources, HVAC, and material selection. And there's a balance point between we wanted to apply passive house principles, but we didn't want to carry it all the way to passive house certification. So we found a compromise that is intended to be the life cycle cost balance point between system efficiency and envelope and construction efficiency. The other aspect of this whole design is it was ultra low carbon in the building, in the material carbon emissions of the building materials themselves, which is a big change from the way we do construction. So what did we implement? What did we trial? On the foundation, there's zero concrete in the entire design. There's no basement. It's built up on structural piles. We use an EcoFlex recycled rubber mat slab on grade. So you can see it there, the kind of the finished product. That is what you would drive on into your garage. And of course, it's recycled tires. So that's quite good from a carbon perspective, reusing that high carbon material and avoiding the concrete, which is the biggest. Concrete makes up 40% of typical residential construction carbon footprint. So we have a lot of wood in the design, and then we added in the insulation levels, we added hemp and sheep's wool. So those two are very low carbon. In fact, they're negative carbon over their life cycle. We used Shosugiban charred wood siding. We could only do one face of the building with that. And then we added a lower cost, higher carbon footprint. But metal siding is actually quite thin. So the actual weight and mass of the metal is not that bad, but it has a very good durability and longevity. We still use drywall. There is Certainty Drywall has a low carbon drywall producing facility now in Quebec, and they're planning on converting their other facilities. So you can actually get drywall now that is 60% less carbon than what we have. We just couldn't get it in time. It was only available the beginning of this year. Light zone windows, I'll get more into that. These are, in my opinion, the best windows on the planet. They're invented in Edmonton, Alberta, and I've looked at all kinds of windows, and these outperform any of them, and have a 30-year warranty. Very, very high performance. The roof and floor, we did use polyurethane insulation on the roof. You can reduce the carbon footprint on that by adding biochar. It reduces it by about 20 to 30%. And so it's a good option. It gives us our high performance roof, and it avoided condensation issues that we'd have with cellulosic fill, which is the original design. And then we have a PVC roofing membrane instead of a high carbon membrane. This will still have some carbon footprint, of course, but we want to make sure our roof is in good shape. And you can see some of the real construction pictures there. And the bottom right picture will draw your attention there. If you look at all those structural piles, 34 piles are required for the structure, and we converted all of those piles into energy piles, which I'll get into in the energy source section. Here's the light zone window broken out. This is the 6-pane version, which we have on one level. We have a 4-pane version on the upper level. So it's 1 pane of glass, and then here's 4 panes of thin film plastic, and then followed by another pane of glass. And this gives our 17.5 for the core of glass, and about R16.5 for our larger windows with wooden frames. And we focused a lot on sealing these windows in, but that's a super high performance window. This would meet Passive House standards. It is certified for Passive House. Even the level 4 window is quite good. It's an R11.5 center of glass, and that's on our upper level. So highly recommend these, but there's a lot of cost to them. And so what they have done is a frameless installation. So you can get just the integrated glazing unit, install it in your rough opening, and just button it up, and you don't have to buy a frame at all for fixed windows only. For operable, you need a frame. On the water side, we've got another Canadian pioneer with this recirculating shower, the Rainstick shower invented in Kelowna. It recirculates 80% of the water and thereby saving 80% water and energy. So that's a really excellent innovation. And they're basically treating the gray water from the shower directly. What we'd like to do in the future is develop something similar that treats the entire bathroom, which is all light gray water, except for the toilet. We would treat all the light gray water and recirculate it right back to the point of use inside the bathroom. And since Rainstick was certified, we believe that's possible. We looked at gray water recirculation for the whole house, but that was cost prohibitive, and that's why we're looking at a future version of that. Some other future things we were looking at is having Zipgrow towers on the rooftops. We have a flat rooftop. We can add the greenhouse, and we calculated that with this size home, there's a 2,500 square foot on 2 levels, so 1,200 square foot on the one upper level. If we had 8 of these homes, we could service the entire vegetable production for the city of Okotoks with just 8 homes with these Zipgrow towers. So it's a very high density food growing opportunity. And when we integrate the Zipgrow towers with the other water recovery, gray water and tilapia fish, we create basically a complete ecosystem for the water cycle. Those are future. That's in the next version, but we had enough to experiment with on this one. We apply for the source energy PV thermal, which is a hybrid collector. You can see it in the upper right. It's got fin tubes on the backside, coils that circulate glycol through it, and then PV cells on the front. By doing that, we get 4 times more total energy. We make our PV cells more efficient because we actively cool them during the summer. And then we take the summer heat and we store it to use during the peak of winter. And we can also use it during shoulder seasons to service our heating loads directly. Electric vehicles are very much part of the design. They're part of the electrical load. We produce 3 times the energy the house consumes, the extra twofold service the EVs. And we're also planning to use bidirectional chargers, which will be coming soon to us. Emporia's by the end of the year. Decibel works in California. Wallbox we could possibly get now. Thermal storage, this is really important. So we have a number of different thermal storage elements, and we're trying different ways of overcoming the air source heat pump issues when it's below -15 and below -25 when they don't operate with today's heat pumps. So what we do is when it's very cold outside, we rely on these thermal storage elements. Those energy piles are heating the ground that's about 1,800 square feet and going 12 feet below the surface. And that capacity is basically almost 40% of the annual heating demand. We only need to cover the very cold days, which is less than a month of winter operation, much less than a month. It's probably in the 8 to 10 day range that we need to cover where air source heat pumps are not effective. And so the other way of doing that is to have a medium-term storage tank. Now, ours is fairly small in this design, which is about 400 gallons, and we get 100 kilowatt hours there, but that doesn't last very long. So we would want to see something closer to 2,000 gallons to make it through the winter cold snaps, which can run 5 to 7 days of cold where you don't have an opportunity to recharge. And to augment that, we've added phase change material storage, which when we charge it up, it stays at that temperature. So there's phase change material storage actually in every single one of these storage elements. It's in the energy piles. We inserted phase change material tubes inside the steel pile. We have it planned for our medium-term storage tank, and it's in our domestic hot water storage tank. That's a product by Sunamp out of Scotland. And of course, all of this needs to be intelligently managed. We have a solar inverter that does most of it, and we work with Emporia to manage and monitor the AC loads and the EV chargers. How do we heat and cool? This is a really interesting part of our application. So we have created a dual air to water source heat pump by converting an air source heat pump to allow it to also do water to water. We use hydronic to deliver the heating and cooling. That's the fan convector. And then the HVAC system is really only for ventilation. But our ventilation system, you can see it looks quite complicated here. What it can do is it's all demand controlled ventilation. It can recirculate and filter the air. That little box at the bottom there with the little down and up again, that's a MERV 13 filter on the supply side. There is a small unit heater to top up the heating after our 80% efficient energy recovery ventilator. And then on the far right there, you can see that vertical box is a UV light. So we can even treat for pathogens and viruses. And University of Calgary is working on detectors so we can have sensors that measure the virus level in the air, and you can automatically turn on your UV filtration to purge the house of that pathogens. So this is effectively, other than a surgical operating theater, this is the best, healthiest way you can manage your ventilation. And actually, it's not that costly because we're attacking each component of the system and providing a direct solution for it at about an eighth of the cost of what we paid for the prototypical. Here's our dual water air source heat pump and our selection. It's quite a large heat pump. It's 5 tons at rated capacity. That's at 7 degrees Celsius, but we would run at -15. It's only 8 kilowatts, which is even more than we need for this house. There's a lot of innovation in this, how we use the solar with the refrigerant circuit in this heat pump. Some of that's proprietary, and we're trying to expand upon that to provide the most efficient air source heat pump and extend the operating envelope for it to operate even below -15 efficiently and to operate down below -30 as well. Our low carbon materials, we talked about a little bit. The sheep's wool bat we used a lot of sheep's wool. This is a really good insulation for moisture management. If it gets moist, it can dry out. It does not lose its insulation capacity. Virtually any other insulation, even rock wool, will lose its insulating capacity if it gets moist. We have special membranes that are passive house rated that allow our walls to breathe out. So if they do get moist, they'll dry out. We also have hemp panel outsulation, 2 inches continuous across the entire exterior. This gets rid of thermal breaks on the studs and gives us a very high performance wall system. But here's the balance point. We started with an R40 wall, and we analyzed the cost savings over the life cycle, and we determined that if we went with an R20 wall and gained the interior real estate value, it was much more cost effective. And from a real estate perspective, it's a $75,000 improvement. And the savings on our energy system was one PV module, or about $500. So it did not make sense for us from a balance point to go with a very high performance wall. We have the high performance windows, of course. So our windows and walls almost perform at the same level. And then we have reasonably high performance roof, and we'll see how that plays out in the energy analysis. There's some of our siding materials. That's metal siding that you can see there. I didn't show the show Sugimon here. And you can see the structural screw piles for our foundation. By eliminating concrete, we save over 50% of the total home carbon by switching to high carbon screw piles. Now, our screw piles were over designed for the project. We can probably get away with even half that metal content for the foundation. Metal siding does have a high carbon, but it's very long lasting. We do have some steel studs in the lower 1.2 meters. I think someone mentioned the floods in 2013. Our design here was intended to respond to that. This is 4 feet high up. It's flood resistant or flood proof. All of the materials in that bottom 4 foot could be flooded and will dry out and recover after a flood up to 4 feet. So that's pretty significant flood. In our location, the entire town of Okotoks would be underwater. So we think we're pretty safe from flooding, but we wanted to prove you could put this in high river and it would work. Mechanical systems do make up about 40% of the home's carbon footprint. We don't have all the ductwork that you have for an air side distribution system with conventional air duct sizing. We only have, it's a 200 CFM unit for each level, so very small ductwork for the supply and return. So that saves a little bit, but it's still something that needs to be worked on. And then I'm going to try and play this video. I'm not sure if the sound will come through, but don't hear any sound. Just anyone hear any sound? I don't either. So, so this is, it would be better if you could hear me speaking. There's lots of speaking parts, but I wanted to show it's a factory built home. So it's built in the factory first. We do about 75 to 80% of the work in the factory. We complete the interiors, including up to interior paint. And then we brought it out in 3 modules and craned it in place. This is the actual crane day. It took place over 2 days. Could have been done in one if we'd had good weather and no wind. Um, we crane it in place on top of those structural piles. So that saves us a lot of time uh, that you to avoid the elements in construction. So we started on site March 20th, and we're almost done now by the end of May. So, and that's with a prototypical construction. When we have this lined out, it should go a lot faster. You can see how it's a significant effort to crane it in place, but there's some savings there, of course, in construction time. There's no savings at this scale unless you're doing 10 or more of these units and they're all similar when you use the factory. Because inside the factory, the trays are exactly the same, take the same amount of time and effort inside the factory. It's just you're protected from the environment. What you do gain on is quality control. So our envelope, all of our systems, we have really excellent quality control. And when you line it out with a finalized design, you'll be able to produce a much higher level of quality, especially when it comes to air tightness and insulation value for the home. I think not too much more I want to talk about since the sound's not working. Um, over that, you can see, let's go back to that. Stop it there. So you can see the 3 modules here on the lower level there. Just, I don't know if you can see my mouse there, but by the red crane part, that's one unit A. And then just to the east of that is a small bedroom module. The garage walls were built up on site just enough to support this upper module. So that upper module is going to swing into place over top and run in an L shape on top of those other modules. You can see them starting to swing it over. So that, and there it is in place. You can see how the factory construction worked and how that could be extremely valuable to northern communities and remote communities where you can have a home built and you drop it on place and it's basically ready to occupy. And I think we'll stop there.
Great. Thank you, James.